Hey everybody, let's do another leetcode problem. Yesterday's medium one was a little bit too easy, so let's do a hard one. This one, reverse nodes in K group. There's a comment here, so maybe I looked at this. Okay, let's just try it. Given the head of a linked list, reverse the nodes of the list K at a time, and then return the modified linked list. Oh, I guess this is not from me. This is defining what the list node class is. All right. So we're given a head of a linked list, and we want to reverse the nodes of a list K at a time. What does at a time mean? And return the modified list. K is a positive integer and less than or equal to the length of the list. Okay. Yeah, don't alter the values, only change the order of the nodes. Okay. So here's an example where K equals 2, there's 5 elements. Okay, so reverse 2 at a time means every 2 nodes, you make that like a sub list, and you reverse just those. So it goes 2, 1, and then you skip to 3, 4, and reverse 3, 4. And 5 is just left alone because there's not enough to complete it. Okay. Yeah, so there's some small examples. The number of nodes in the list is n. K is always going to be less than n, less or equal to n. And the value is less than 1,000. I don't think we care at all about the values, do we? I wonder why they specify that. Let's see. Because we're not sorting or anything like that, as far as I can tell. Okay, and the follow-up is solve the problem in constant memory space. Okay, so probably there's a naive solution that uses linear space. So basically caching the list. So yeah, I mean that kind of hints at naive solution. Maybe you just copy the list exactly, and then create a new one as you go. Yeah. Yeah, in theory it doesn't seem that difficult. Basically we'll just, one thing you can do, maybe I'll draw something. Where's my drawing thing? Yeah, so if we have, not putting the actual values, I'm just putting the, so let's say K equals 2. Basically you can create a stack as you traverse the list. So your stack is going to be 1, then 2, and then you can pop off the stack every time you hit 2, and then you end up creating a 2. This is, I'm not very good at drawing like this, but you can see how, yeah, you'd be able to create the reverse order of the stack, which stacks are good for. And that seems okay. Let me think about this. I think this is still, so that's dependent on K. is the yeah, it's a little unclear if that's constant time or not. But let's say it's not, because they allow k to grow to as big as n. Okay, so let's try to think about how to do this. This was eraser, but it's an eraser that I don't know why it's not erasing, but okay, so the background color here is gray. Anyway, how you do in constant time that's not dependent on k? Well, as you go down the list from 1 to 2, what you can do is start creating another list. Actually, you need to do this in place, and you can't swap the values. So you're gonna have to do this with some kind of pointer modification thing. This list just has next, I think. You can see list node only has value and next. Yeah. So what we'd have to do to reverse. So the next is just pointing at that one right now. We'd have to somehow, as we go down the list, just change to point backwards. Yeah. So that means also the thing that 1 is pointing to, we want to set it to null at some point. Yeah, it seems like this is pretty doable. Let's try and write the solution. It seems a little too easy, so I may be missing something. Any other ambiguous parts of the question we want to ask about? Yeah, it's a pretty well-defined question. Structure's given to us, and we know it's not going to be crazy size. I will say 5,000 is a number we probably don't want to use recursion on, because we could blow up the stack. That's a very deep stack if you use recursion, so we probably want to do this in a while loop. Or possibly, yeah, I'm not sure if we even want to use a helper, but so let's try to do this in place. In place, reversal. So what are we doing? Every node. So we're always starting at a head of some sort. Set head. So I'm just going to do it here. Initial conditions. The previous is null. Okay. And then the next thing we do is we want to flip reduce sub length. So sub length is the length of the k. Or increase. So you can also talk about increase sublen. And we also want to just, each time we reduce the sub length, we want to set previous. there's one major problem we're going to run into, is that if we're doing this in place, for the last one, we're going to run into a real problem. Looks like somebody was texting me about a move. Anyway. Okay, so for the last few, we have to flip them around. We're going to flip them around with this algorithm, but we don't actually want to do that. So one possible thing we could do is like do a quick look ahead to see if we have enough space. Yeah. See if we have enough remaining length to reverse. If not, return. Okay. So what this is going to do is we check, in this case k is 3, right? We check, we send like, we keep the current pointer pointed at this first node, but we send like a scout down to see if we have a length of 3. We do, and then we actually begin reversing after that. And then we advance the 4 as the next head, and the scout says there's not enough, so we stop here. Yeah, and this doesn't consume extra memory. It just, I mean, it consumes one node of extra memory, I guess. You're computing a little bit more, but that's fine. That doesn't take up memory. Okay, so initial conditions. Let's just start coding. Rev equals none. Cur equals I guess we can just reuse head. And then another thing we can do, and let's point out we need to handle null case, handle empty list case, because it's optional, right? Although they always say, oh no, yeah, they say n is at least 1, so I'm not sure why we have to worry about that. Maybe that's for the recursive case, I'm not sure. Yeah, so it's valid to return none, which is interesting, but I think the contract doesn't allow that. So I would potentially consider at least on the, yeah, I don't know. That could be something you could discuss a little bit with the interviewer, just to talk about tightening the contract or if there's a reason for that. Okay, so so even though these are the constraints, because the contract specifies this, I'm going to handle that case. All right. So now we have a runner. What we do is this is going to be in some larger while, right? So we're going to need some like how about this? I like this a little bit better. We'll define has enough length. And then, yeah, we also just take one of these guys. We'll just use this. Let's call it something else so we don't collide, even though the scoping would let us do this. Subhead. Okay. And let's just, I mean, it's debatable whether or not you need to write those out, but let's just do that. Okay, so we'll just reuse K here. Sorry. For IDX in range K, if subhead, if not subhead, return false, right? And then the other thing, we have to do is update subhead next. Then if we actually are able to get the result, we return true. So this is nice because it handles that initial case. And now we can just make that our loop condition. Has enough length. Yeah. Okay. And now we can just reverse the thing. So again, we are just okay, and the one tricky thing is we have to keep the reversed head and return that, right? So think about this. Yeah, I think this will work. So whatever, here we reverse the thing. So the new head is going to be the last element we process, yeah? Let's just remember we have to handle that. Okay, so we're going over K again, and each time, what did we say we do? So we do need the previous node. Right, so we will need like a previous, and it is none originally. Let's all set reversed head to none. Okay. So we're going over k, and basically we can just, we have to save the next. Let's call orig next equals head. I don't think I need a curve, but I'm just gonna make one. Yeah. Okay. So we're saving the next, then we set next to none, or next to the previous. Yeah. Pre equals cur. Right. And I think that's good. So let's just quickly verify this. In this case, we set orig next to the prev next, which is null in that case. Or sorry, we save the next, which is 2. Forgot to update current to orig next. Okay. So we save the 2. We set the next to null, and then we do some updating. The next time, we save the 1, we set the 2's next to be 3, and so on. And this should go for 3 steps, so we should also do the 1. We set the next of the 1 to point to the 2. Yeah? Of course, it'll be working on the top, not the bottom. And 3 was originally pointing at 4, right? So that's going to be saved in orig next, which will be cur here. So when we're done, we also need to set so the orig next in this case will be 4. That means cur will be 4. So the very last thing, if we didn't have enough length, what we have to do is take the orig next and point it backwards. Yeah. If we had like a even, like a what's that called? Evenly dividing number nodes, if it's 6 nodes here, cur will end up being null at the end. But if we're not able to fully reverse everything, then cur is going to be none. So that means we can use cur here and update it after the loops. Done. The final subhead wasn't reversed. Yeah, okay, I think this kind of works. And then the other thing we have to do is return the, what's that called, reversed head. So one tricky thing here is the reversed head is going to be something, it's going to be the end of the first successfully reversed thing. So the reversed head equals prev here, but we only do it only want to do that if we are still pointing at the original head. I think that should work. All right, let's look at this quickly. I think it makes sense, pretty logical. We can just transmit, see if it works on these test cases. Probably have syntax errors, we'll see. No syntax errors, but we're not doing somehow we're terminating very early. So has enough head should work on cur, right? Yeah, so in this case k was 2. Let's just walk through it. Have enough length should be going over, idx should be 0 and 1. We should not be returning false until the 5 node, right? Okay, so let's assume that's okay for now. We can debug later if we need. Then we actually want to reverse the list. So what are we doing? So the good part is returning the correct reversed head. But here's the thing. Remember we had the original previous set to none? We actually have to go back and update that, right? So we actually have to do that here, I think. So when we're setting the reversed head, we can do that. And we also want to set head.mix to be cur. Yeah. Is this something we have to do only once? It may be. Let me think about that. Interview, I mean, I could write another test case here that's a little longer. I want one with at least 3 groups to test this. So, like that. But in interview, they might want to see you work it out a little bit. So let's see. So how would it work? In this case, we'd have a special case of looping the 1 to point to the 3. Is that right? 1 points, but the 1 really should point to the 4. Yeah. Yeah, the 1 should point to the 4. Ooh, so that is a little tricky. Because we actually, yeah, so that is tricky. You have to wait till the second sublist is reversed before you can update the first head. So that suggests you have to keep in memory this 1 for at least 2 times k nodes. Okay, so that is tricky. I missed that. So how can we do that? Yeah, the way we have it now, we're going to miss out on some things. So as a hacky solution, you could just have a final runner actually do those updates if the list isn't broken, but the list actually might be broken if you do it like this. Yeah. I wonder if it's better to start at the back somehow. No, but then you're, yeah, I don't think you can do that. Yeah, so very interesting, huh? You have to first reverse the 1. If you do it like this, there's no way you can know, you have no easy access to from this 1 to this 4, right? There's any, this is for 2, k equals 2, but it could be much bigger. So you have to essentially reverse 2 things at a time. Maybe that's okay. Maybe that's okay. So what could you call that? Previous subhead. You can call it that. Should it also be head? I'm not sure. Let's just see here. So the head.next. This setting head.next equals cur. That is actually useful if you and it's not, yeah, this is not something we just want to do once, so let's break this part a little bit. so here we are keeping track of the last two subheads, which is, is it the start? This is getting very confusing. Yeah, this is a great problem. I like this problem. This is something pen and paper will help you out a lot. I don't think it's going to be easy for me to draw in the that sketch thing. I'm just not very good at that yet. But yeah, pen and paper becomes more important the more arrows you have to draw. So I'm just going to grab my notebook and sketch a little bit. Maybe in the future I can find a way to share this. I mean, for like online interviews, it might be useful to be able to share pen and paper anyway. Okay. So the things I'm trying to keep track of. So I want to keep track of the original head, which is 1, because this is the thing we have to update later to point to the other thing. And this other thing is actually the last thing we run into. So that's going to be prev when we finished reversing. Yeah? Prev subhead dot next prev. Yeah. So the reversed head, that is now the new subhead. Right? Will this be good enough? I'm not saying subhead anywhere, so I need definitely to do that. And yeah, we can just use subhead here. Since occurs like this thing we're moving just in the loop. And this might be better. I'm not very confident in this, but let's try it. Okay, so we've messed up horribly. Somehow we've created some loop where we're not finishing. Oh yeah, so we're not incrementing subhead enough, I guess. I mean, in a loop, so we don't care about subhead in the middle here. Wait, maybe we don't care about subhead at all. Okay. So I'm still advancing cur. previous subhead. I think this can be an else because we only do this after we've done with the second loop and beyond. And oh, there's no subhead anymore, so this is also wrong. What I'm trying to say is previous subhead is now the new head, right? This is why naming your variables correctly are very important. So previous subhead, I want this to be the thing that was originally the subhead, so that would be the 3. Oh yeah, so I do need to keep that subhead. Okay. Okay, so what is this now about never terminating? I find this very strange. We haven't changed the loop conditions, have we? So let's just add some print statements as debugging because I'm not sure why. It's not value. Oh, it's a val. Not sure if that means can't show us the print output because it hasn't terminated. I'm just going to like test that by just putting a hello here. So where are we blowing up? We're using a lot of memory. Okay, so it's not able to print anything if we exceed the memory limit. so the prints aren't going to help us really. Yeah, before we were exiting, as long as we increment cur, it should be good, right? Orig next. Where's orig next? So what we're probably doing is looping in a circle. It's weird that it says memory. I'd expect this to be like a time limit. I don't see where we would use extra memory. Yeah, but it looks like we're going in a circle now. I don't know leetcode enough to understand why it's a memory limit, but that's not our problem. We are exceeding certain limits. Yeah, so probably doing this is making us loop. Let me just verify that. Yeah, so previous subhead. Previous subhead also starts out as null. The first time we ignore it. The second time we don't ignore it. We set it to prev. So we reverse two things. Previous subhead, it should be 1. We want to set 1 to the 4, which should be prev, right? Because we finish the loop by setting 4 to point to 3, like this. And that's cursor to 5. So 5 is cur, 4 is pre. When we finish cur is 5, right? In that case, we don't want to set 5's next to prev, which is going to be 4. That's essentially causing this infinite loop. I'm not sure you want to do this. Right? The only thing you have to do is make sure 3 is pointing to 5. Just like we had the 1 point to the 4. So I think here we want to do prev subhead I want to do it like that. Let's try that. Alright. So a little tricky, but we've passed the test cases. Let's try the full problem. And yeah, this fails some test cases. So we forgot to handle the important cases, like there's just one element to reverse. We could obviously just check if k is 1 and return the original head. But just quickly understand, if there's some we're filling other test cases, so there may be algorithmic things that we could adjust. So when k equals 1, we actually skip the first guy. And why do we do that? That is strange. We're probably it's probably because our reversed head here, which first time, okay. So what we want here is the last element in the list. And I thought that should be prev. Let's step through this. Okay, so range of 1 gives us a 0. We do a rich.next. We set current.next to prev, which is going to be a z, is a null, yeah. And prev should be current node. I'm missing why this is returning the 2 instead of the 1. Because we only return reversed head, right? So this only happens the first time. And prev should be the 1. We don't increment prev. Let me do this. Let's check. Let's just check print prev value. Oh, I forgot to put the code, sorry. Val. Oh, we're actually hitting it twice. It's because in that case, reverse head. So let's check for none. That's the safest thing we can do. Let's do reverse head. So I think there's a case where we don't have enough length and we still need to return something. So how's that? Okay. We'll have other things broken. This only passed 54. Oh, okay, that was it. So yeah, this looks like a reasonable solution. I think it went a little slower than I'd like, but I have about 45 minutes in a problem. I think it's just enough. But yeah, let's see what we could do better. Let's ask Gemini. The solution was not correct. Please tell me how to improve without paste it at the top here. So yeah, let's put that there. And while this is happening, I mean, we can do things like write our doc string. Just be good to check the interviewer in case they want that. Yeah, there's probably an extra variable here I don't need. But let's see. So Gemini says in place is good. We could have used a dummy node. You can use reversed head to capture the new overall head of the list, but only for the first group. Okay, I'm not sure exactly what their solution is, but I'll ask for the solution in a sec. They actually ask for recursive step. Let's see. Doesn't mention possibly blowing up the stack. Yeah, 5,000 is a lot for a stack. But, and variable names, yeah, subhead's not great, I agree. Group start, I like that. So, yeah, group start would have been better. Let's ask for now give code solution. These changes. Also, for the recursive solution, they thought this was dangerous due to potentially blowing up the stack. 5,000 deaths. Okay, so yeah, we would probably want to call subhead group start. Like original group start is what I would call it. Like that. Previous original group start. It's also a mouthful, but it's slightly clearer. Yeah, a little bit better. Let's see what Gemini said. Of course. Yeah, they concur. Recursion limit is not going to be great at 5,000. I mean, it's also just that's also violates the memory constraint because then it makes it dependent on n potentially. Because a stack is just pure memory. But it's defending its solution. It says it could be elegant. No apology. Usually apologizes when it's wrong. Improved iterative solution. Okay, this is what they do. kth node. I don't know. This looks more difficult to read. Yeah, it's doing something very similar. Okay, so it's reusing the dummy variable probably. Oh no, it's not. But yeah, one interesting thing is for like flipping the groups around, they don't, there's no if statements. Wait, this cannot be a complete solution. There's no returns. Okay. Yeah, this is not a complete solution. Okay, I'm gonna ignore these. Sometimes Gemini doesn't do that well for the hard problems. And I think our solution is pretty good. So that'll be it for today. Thanks. And see you tomorrow.